All right, guys, so on the 2019 polar coordinates problem, this one starts off fairly simple, and it gets very complicated in letters C and D. So hopefully you can kind of understand what's going on here, but this does get a little, I don't want to say out there, but this one's definitely one of the more challenging polar questions I've seen. So let's go ahead and jump in. You look at it initially like, okay, this isn't that bad. Let S be the region bounded by the graph of polar curve R of theta equals 3 times the square root of theta times the sine of theta squared between theta and the square root of pi as shown in the figure above. So we've got this graph, and we're like, okay, I'll just deal with this graph. I'm sure it's not that bad. Letter A wants us to find the area of S. Well, in order to find the area of S, this one's actually pretty simple because it tells us from what angle to what angle we're going to draw our polar graph. What we're going to do is we're going to go 1/2 times, we've got r of theta squared, and then we put that in d theta, and we put that into our calculator, we get 3.534. So again, not that bad on that one. That one is actually pretty simple as far as what we're supposed to do to find the area. As long as you know the formula to find that, that's not that big of a deal. Letter B wants to know the average distance from the origin. Well, this tells us the distance from the origin. If we want to know the average distance on 0 to pi halves, from 0 to square root of pi, we are just going to have to find that distance, not the 1/2 this time, 3 square root of theta times the sine of theta squared. And then we're going to divide that by our time interval, square root of pi minus 0. When we put that into our calculator, we get 1.5799 or 1.5780. Either way works. That's your answer for letter B. Again, not that bad. Now, letter C is rough. Letter C says we've got a line with a positive slope that divides the region S into two regions of equal area. So we've got this line that's going up just like that right there. Okay? And it says, right, but do not solve an equation involving one or more integrals whose solution gives the value of m. So I know, since it's going to cut that region in half, that I'm going to have that 3.534 that we got from letter A divided by 2. That's what it's going to be equal to. The problem here is I set up my integral, and I know where to start. I'm going to go 0 to, I have no idea what that's going to be. I just know that I'm going to have 1/2 times my r of theta squared. So that's going to be my area. And if I can figure out what m is, then I'm good. The problem is, if you look at this, you're like, oh crap, and there's a lot of different ways you can go about finding this. But what you have to realize, and there's, again, lots of different ways, this is how I thought of it. From here to here, if I think about this, if I were to make myself a right triangle, okay, like that, I would go over x coordinates and up y coordinates, okay, whatever it is. I don't know what that point is, but I know I'd go over x and up y. So I could say, if I were to look at this angle, which is what I'm looking for, I could say that the tangent of that angle is equal to x over y. Well, if I know what x over y is, or y over x, because that's just what it is, that is the slope of, or that is the equation of that line, okay? That would be the slope of that line, So, if I wanted to, I could take the inverse tangent of that, and that would give me that angle. Now, again, that is a really difficult idea to kind of wrap your head around, but that's how big the angle has to be. Whatever the equation of m is, that would be the point up there, if you will, or the positive slope, The slope would be m, because that would be y over x. The tangent of that, the inverse tangent of that would give me that angle, so we're all set up. Now, again, that problem was difficult. That was one of the more complicated problems I've ever seen on a polar equation until I saw this one, okay? This says, for k is greater than 0, let a of k be the area of the portion of the region of S that is inside the circle r equals k cosine of theta. Find the limit as k approaches infinity of a of k. So this is basically saying we're going to draw this polar graph with k cosine of theta. Now, the reason why this is so difficult is in order to understand this question, and you could play with your calculator for a while to figure this out, but the cosine graph, what it does is it does this. Regardless of the number that's out front, it starts out here, then it goes back to the origin, then comes back around. In other words, it never goes into the second or third quadrant, and how big this circle is depends on the number that's in front of cosine. So the bigger that number is, the bigger this, it's not actually a circle, but the bigger that circle, it is a circle, the bigger that circle gets. Well, this is saying that that circle is getting really big. What that means is eventually the circle is going to be so big that it's encompassing this, basically the entire first and second quadrant. But the first quadrant is the only place where S is located. So what this really wants is just the area in the first quadrant. So all I have to do is the integral from 0 to pi halves of 1/2 of my r of theta that we got earlier, squared, d theta, and it turns out that that is 3.324. Now that one, honestly, it's not that hard to realize, but you have to know what this graph does. We haven't talked about that a ton in class, unfortunately, and that's probably why this gets so complicated and why this one's so hard. Like I said, C and D on this, very specific, especially letter C. D you might have been able to reason out if you drew enough polar graphs on your calculator to kind of figure out what was happening as K got larger and larger. The letter C, really tough on this one. Anyway, hopefully both of those kind of make sense, and the rest of the problem kind of made sense as well. If you have any questions about that one, please let me know.